Welcome back again. We are going to conclude our brief introduction into object-oriented programming by talking about polymorphism. Okay, and man, sometimes it's just the words want to come out and they don't come out, but they came out. So polymorphism, that's a hard word. That's a hard enough word to say as it is, and it's a question that's often asked in interviews for jobs, which is funny. There was like, can you please define polymorphism? And you're like, what do I say? Because the definition's so hard. The implementation of it is so easy, but the definition is pretty hard. So we're going to say define polymorphism. Define polymorphism. The condition of occurring in several forms. Ooh. The occurrence of different forms among the members of a population or colony, or in the life cycle of an individual organism. So it's talking about, this is just generic definitions, right? It's talking about having different forms occurring in several different forms. Interesting, right? Occurring in several different forms. Here's another one. Someone please define it in 2 sentences. Polymorphism allows the expression of some sort of contract with potentially many types implementing that contract, whether through class inheritance or not, in different ways, each according to their own purpose. Code using that contract should not have to care about which implementation is involved, only that the contract will be obeyed. I like that one a lot. And this is a programming definition. So you're going to create a contract, and then different things can implement that contract, but they do it in their own way. And you're probably super confused right now, and you should be, because that's a textbook definition. That's computer. That's what they teach you in college. They're like, let's see if we can confuse our students and not teach them anything practical, but teach them things that don't make any sense. So let's teach you what they're all about. Great. Get started with the playground here, and we're gonna call this one polymorphism. Okay, put it here in Swift. That's great. The principle is so simple. Once you watch me do this, you're gonna be like, "That's it." And that's how you should lead in your interview question is by talking about, well, let me just give you an example instead. So what we're going to do here is we're going to create a class called shape. Okay. And we're going to have a property in it called area. Okay. Var area of type double. It may or may not have a value in it. So we'll put an optional at the end of it. And we're going to create a function called calculate area. Ooh. Okay, now here's our base class, and every shape's going to have a calculate area function. Okay, so here's the advantage of working with a base class. For instance, let's say we didn't do this, and I wanted to get a rectangle's area. So I would say class, and then I would have to go and say rectangle. Okay, and then I'd say var area of type double. And then I would say func calculate area. Okay. And then area would be, and then we need to pass in a length and a width here, right? So length of type double and width of type double. And then we would say area equals length times width. Okay. And then all of a sudden the boss is like, oh no, we need to also create a triangle. So we're like, okay, we're like triangle. And we're like var area double, and then we're like func calculate area, and then we get a base of type double, and what is it, base times height divided by 2, I think so. So we get the height, which is a double, and then so we say, area equals base times height divided by 2, and we'll just put some parentheses operation. Okay, so we've got 2 classes, both doing similar things, but look at this. We had to recreate the area property. We had to recreate this property here. And what happens if in this case, one programmer gets lazy and they're like calc area, and this one's just like, let's get area. So now things are becoming inconsistent and the parameters start changing, base value. And it's just not really good. We're rewriting code. We could break our logic. This is all trash. Trash, trash, trash. Get rid of it. You're fired. Can't work here anymore. I'm just kidding. I'd still hire you. Okay, so how do we fix this problem? How do we make things more consistent? Well, we can use polymorphism. And what we're going to do now instead is we're going to create a new class called triangle, of course, but this time we're going to inherit from shape. Okay, inherit from shape. And all we have to do is obey the contract, which is calculate area. So what we can do is we can say, I want to implement calculate area function, and we override it completely. And then all we have to do, actually this is wrong. This needs to have the values in it. So let's put value A of type double and value B of type double. Okay, now we can calculate the area like so. And then all we need to do is say area equals val A times val B, like so, divided by 2. And this is of a triangle. Okay. And in this case over here we want a rectangle, so class rectangle, and that's going to inherit from shape. And we do the same thing here, calculate area. But in this case, area equals val A times val B. So that's interesting. We've got two different shapes here implementing the exact same function, but the logic inside is different, and that is polymorphism, okay? This is one form, okay, with different, or this is one object or form of an object, but that is taking different forms, like so. Okay, so we're obeying the contract, like we saw in that really great Stack Overflow definition. We're obeying the contract in both these cases, but they're both doing something different, and we're still using the same parent class. And that's what polymorphism is, and you use it all the time. So next time when you go in your job interview, if you can't remember the definition, be like, well, let me just give you an example. Like, so when he says, give me the definition of polymorphism, say, let me give you an example. Imagine that you have a shape class, and you have to calculate the area of shape, but you don't know which shape is going to be passed in at runtime. So we create a calculate area function, and then we also create two more classes, like a triangle or rectangle, that inherit from shape, and then at runtime they can each perform their own area calculation and assign it into the area value. And so it doesn't have to know beforehand what type of shape you're picking, because you have the different implementation for it. Or you could say something like that, and they'll be like, oh, that's a really good example. You know, same thing, you know, if you're building a video game, you know, you might have a humanoid class, and a humanoid class is just, you know, a base parent class, and then the humanoid class might have orcs, because they're humanoid, they got hands and feet, they can speak. And then you've got elves, but you know, elves are magical and mystical, they can do their own things, and orcs are brutish and, you know, ugly. So you got to put an ugly modifier on there, and that's actually real. That's a real example in games like World of Warcraft and other things. They are using polymorphism and inheritance all over the place. So that is polymorphism. Simple principle to understand once you do it, and you're going to do it a lot. So that's it. Mark Price at devslopes.com. Polymorphism. Sounds cool, mystical.